So today we are going to talk about lenses, alright? So everybody knows what lenses are, and I'm sure you have played with magnifying glasses. And so today what we are going to learn is, we are going to learn how lenses form images, right? And then we'll also learn how to find the location of the image, size of the image, and orientation of the image, and so on, right? So there are two types of lenses. One is called a converging lens, and another one is called diverging lens, right? So I'm not going to use the name convex or concave because soon you'll get confused or can mix up between the two, because the naming convention for mirrors is also opposite to that, right? So I'll just use converging lens and diverging lens. So first of all, the first concept that we have to talk about is something called a focal point. So let me draw a converging lens first. Converging lens, then I draw like this guy. So the center I'm not going to draw because it's hard for me to draw like this, and that's the center going through the center of the lens, and this is what we call the axis of the lens. Okay, this is called the axis of the lens. So now, why do we call this converging lens? The name suggests that when we send in light rays parallel to the axis, so this is the axis, so light rays parallel to the axis, then they will go through the same point. So all light rays coming parallel, if I draw more, they all go through the same point, and this point is called the focal point. We indicate with capital F, and the distance from the center of the lens to the focal point is called the focal length. We write with small f. Okay, so from here to here is the focal length. Right? And the light rays converge, actually really go and meet here, and that's why it is called converging lens. Okay? So in your book, they will use the name convex, right? So they will use the name convex, but I will not. Now, the next one is called diverging lens. Diverging lens, or in the book they will call it concave lens. In this guy, they look like this. So you can think like they cave inwards, okay? So that's the axis. And why do we call diverging lens? Because if we send in light ray parallel to the axis, actually it will start refracting here, but I'm not going to do that. This is the center of the lens. It's always hard to draw. I'll do it from here. Right, the light ray going like that. Another parallel ray, it will go out like that. So these rays are diverging, okay, going away from each other, and they look like they are coming from the same point. And that point is the focal point F for this diverging lens. and the distance between the center of the lens and the focal point is called little f, the focal length for the diverging lens. Alright? Now, what we are going to do next is we need to learn how to form images. Alright? Before we do that, let me introduce something that we'll need later. It's called the power of the lens. Right? It's nothing to do with power in electricity. It's just the power of the lens. And the units is, we write with capital D, or it's called diopters. Right? And it's calculated with power D. In diopters, power is 1 by F. And F is always given in meters, and this power is in diopters, right? So this is in diopters. Or D, and this is in meters or centimeters. Then if it is centimeters, you have to convert it to meters, right? All right. Now let's talk about how to form images. So then we will do something called ray tracing. And there are rules for ray tracing. And in your book, I think it's on page 907. Right? Page 907, you have these rules. But I'm just going to explain to you as I draw figures. Alright? The first one is for, first of all, I'll draw it for converging lens first. Right? So you have a lens, and this is the axis, this is the focal point, and the first rule is that for a converging lens, light rays coming parallel to the axis, see this axis is parallel, then it will go through the focal point. Right? Doesn't matter where it hit the lens, right? It can come here, then it will go through the focal length. It will come from here, it will go through the focal point. Okay? So let's see this. Right? Like that. Like this. If it goes through here, then it will also go through the focal point. Alright? That's the first rule. So anything coming parallel, they will go through the focal point on the other side. The next one. The next one is simple. The next one is if you go through the apex or the center of the lens, if the light rays go through that, it will not change direction, it will keep on going the same. Right? And so the one, if you send a light ray right on the axis, it will do the same thing. Right? So that's the second rule. The third rule for the concave lens, the third rule for the converging lens is the opposite of the first one. What does that mean? That means if it comes through, as we said before, when it comes in parallel, it will go through the focal length. So the thing is, focal point is on both sides. So if the light ray comes passing the focal point, then on the other side it will go parallel. Okay? So those are the rules for converging lens. Alright? Now for diverging lens we'll have similar figures. but with just a diverging lens. So the first rule for diverging lens is like this. If the light ray comes parallel to the lens, parallel to the axis, then they will look like they come from the focal point on this side, right? So this is your capital F for this lens, right? This is your focal point for that lens, right? And it will look like it's coming from there, all right? Now, the second rule is again similar to the converging lens, so it's not difficult to remember. That is, if it goes through the center, it will not change direction. Doesn't matter which way, right? They will not change direction. They will just go through straight. And then the last rule is, in converging lens, we said that if it goes through the focal point on one side, so here, then what will happen is that light ray going through here and if you aim at that focal point, let's do that. If the lens were not there, it will go straight, right? And it will go parallel to the axis on the other side. Okay? So that's how it works. Alright? So what it means is that the first one is light rays are parallel, then after going through that converging lens, it will go through the focal point. The one that the light rays that go through the center, they will keep on going in the same direction. The one that goes through the focal point on this side, it will come out parallel on this side. Same thing here for diverging lens, coming parallel, then it will go diverge as though it's coming from this focal point. Going through the center, they will not change direction. And if you aim at that focal point, then it will come out parallel to the axis. Alright? Okay, so those are the ray tracing rules. So now let's form images. So I'm going to start again with the converging lens. Alright? So remember, for lenses, the focal point can be on both sides, right? So if you remember that, it's easy for you to draw. So let's suppose I have a converging lens here. So this is a focal point, that's a focal point on both sides. And then let's suppose this is like 2f, twice the focal point, twice the focal point. Your book is not going to do this, I'm just doing it, because I think this is better. And so, let's suppose you have an arrow on this side, right? Let's suppose you have an arrow on this side. Arrowhead, arrow tail. Okay? So now the light rays are going to go, and so let's draw the first light rays. And the one is I'm going to start from the arrowhead, hit the lens, going parallel to the axis. So according to our rule, that light ray will have to go through the focal point on the other side. Alright, so it goes through the focal point on the other side. And the next one is I'm going to draw the light ray coming from the head of the arrow going through the center. So according to our rule, it will not change direction. So it will be like that. Right? So you see that these light rays actually do meet at this point, right? Both of them are coming from the head of the arrow, so then it'll be the head of the arrow, all right? So I'm not going to draw the whole thing yet. Now, look at the tail of the arrow. So now I'm going to draw two more rays. One is coming parallel to the axis. So I'm going to use different color. And so it will go through the focal point. Not very good, but anyways. And another one is, it will go through the center. Right, so it's supposed to cross somewhere here. But my line was not straight. So, but both these rays coming from the tail of the arrowhead, tail of the arrow, right? So what happened is, the image of the tail, head will appear here, and then the tail of the arrow will appear here, right? Because, see, these light rays are coming from the tail, these green color light rays are coming from the arrowhead. So the image will appear upside down. So that's how you form the whole image, because the pictures given in the book is a little bit, like confusing for you, because see, they don't draw the lower half part of this image. They draw only half of it, right? So actually, in principle, you have to know that there's a light ray going parallel to the axis, and then there are other things trying to form the bottom of the arrow. So in just, let me tell you what they do. They will draw a lens going through that. I'll do the same thing here. But because for them I can understand, because it will look with all kind of light rays, so it will look ugly. So they do this. So they will draw only two light rays here. One parallel to the axis, going through the focus, go like that. Another one going through the center. So then the image will be formed here. And they will not explain to you how the bottom of the arrow is formed, but that's what it is. So they will draw that, okay? So I'm just drawing the whole picture here, but in the book they will always put the object right on top of the axis like this, all right? Or below it, but they will not do the whole thing, all right? So once you understand this picture, then you will see that they are drawing only half of it, all right? So that's one figure. So if you notice, I put a focal point here. So then from here to here is little f, and from here to here is another f, so this is 2f, right? And then from here to here is f, from here to here is 2f, right? So you see that when I put it beyond twice the focal length, when I put the object beyond twice the focal length, then the image appears between f and 2f. You see? Alright? And looks like it's smaller, and actually it's also smaller. We'll do by using formulas later. Alright? So now what I'm going to do is, if I keep on going closer and closer, this image will get bigger and bigger, and once this object is on top of 2f, then it'll appear right at 2f, but it'll be upside down, and the size will be the same. Once it's entered the region between 2f and f, then the image will appear beyond 2f, and it'll be bigger. Okay? It'll be bigger. Now, another thing is that this image is formed by these two light rays. They actually meet at this point, right? So this type of image is called a real image. So the difference between a real image and a virtual image is real images are formed by light rays actually meeting at that point, okay? And you can put a screen here, then it will appear on the screen like a piece of paper, right? Or a film, that they call real images, because you can see it on the piece of paper, or you can put it on the film and then expose the film that way. And also in the book, they will tell you that you can project it onto your retina. It's a little bit confusing if it's not misleading, so I'll explain to you later. So forget about the retina part right now. But this is the real image. Okay. Now let me draw one more. So now I'm going to this is f. This is 2f, this is f, this is 2f. So I'm going to make the object closer to the lens. Now this time I'll put it between f and 2f. Let me put it somewhere here. Alright? So then the first ray will go parallel to the lens. And as we all know now, it will go through the focal point. The next one will go through the center. It will not change direction. So now they will meet here. Right? And you can see that now the image is bigger, although I'm not drawing in scale. This is actually bigger. And now it appears beyond 2f, twice the focal length, right? Okay. So if I keep on moving towards the lens, this object towards the lens, what will happen is, once it gets to the focal point, we know that when it goes to the focal point, they will come out parallel to the they will come out going through the focal point, right? Or if you put a light object here, then they will come out parallel to the axis. So let me draw this. F into F. Let me try to put it right at F. So this time I make the object green. So first of all, the first guy is parallel, and then it will go through the focal point. The next one is going to go through the center, and it will not change direction, so it will go out. And these two are going to be parallel, so they will meet only at infinity. Alright? Okay, they will meet only at infinity. Now, what will happen if I move this object inside the region between F and the lens? Alright, let's do that. So that is where, this is where you get your magnifying glass, right? Magnifying glass. So this is your F. So now I'm going to put a small object here close to the lens. So what will happen is the first one, the light ray is going to go parallel. You always do that. And it will go through the focal point. Now, the next one is going to go through the center and it will not change direction. So obviously, these two are not going to meet. Okay? These two light rays are not going to meet because they are going away from each other. But if you put your eyes here, this is your big eye here. Then what do you think? You will think that these two light rays are actually coming from one point. Right? From behind. On the same side as the object, on the other side of the lens. And that is what you call a virtual image. Because light rays do not really meet at this point, but they look like they are coming from here, right? Look like they are coming from here. So this type of image is called a virtual image, all right? And another thing is that if you notice, all these images are formed upside down, but this one is upright. That is the same orientation as the object, all right? That's another quality of that. And this type of image is called the virtual image. So now, what about the book written like you can project a real image on your retina? So what about this one? You can also see that. You will project it on your retina. So what they are talking about is, like a little bit confusing because they probably think we're rushing or they're stupid, one or the other. But the thing is, what they are talking about is they are not talking about this lens. They're talking about the lens inside your eyes. So your eyes is like this. Then you have a lens inside your eyes. And light rays coming in, and then they form an image on your retina. This is your retina, right? So that is what they're talking about. So when they say that, projecting an image on your retina, they're talking about this lens, using this lens, right? So here, these light rays, although they are coming from this virtual image, actually, forget about this part, these light rays coming in, going through this lens and form a real image on your retina. So that's what they are talking about, right? So don't get confused. You can see this virtual image also in your eyes, right? Obviously. All right. So that's how you form images by using converging lens. And so you can just put anywhere. So I've done this. So you can put it right at 2F. And if you draw it in scale, you will see that the image will appear upside down at 2F. Okay? All right. So now let's continue with the diverging lens. So with the diverging lens, I don't have to draw many figures. I'll draw only one. Why is that? So let's suppose this is our diverging lens. That's the axis. And that's the focal point, that's a focal point. So I just write F, right? Small f, but actually the book they use capital F. And I suppose I put a little object here. Doesn't matter where I put. So it'll go, the first light ray will go parallel to the axis, and then it will diverge as though it will look like it's coming from this point. Okay. Another one is going through the center, and it will keep on going straight. So you see now you put your eye here, so you are seeing these two light rays coming out of this lens, and you see that this one and this one looks like they are coming from this point, and so that will be your virtual image. So I encourage you to draw. So this is a virtual image, so I'll just put a little bit hash here, but this is just an image. And I encourage you to draw other pictures by putting this object at different places and see how it changes your image, right? So you'll see that after you draw 2 or 3 pictures, then you'll be an expert at it, okay? All right, so we'll stop here.